Okay, so I wanted to go over some things on 4.3, which is on triangles, regular hexagons, and polygons. So triangles are polygons that have three sides and forms 180. We've seen that in some of your other sections. There's different types of triangles. You've got scalene, which means no sides are equal, which looks like this. Isosceles, which means you have two sides that are equal, therefore you have two angles that are equal. And then equilateral, which means all the sides are equal and all the angles are equal. So that means each angle has to be 60 degrees. Let's go back. So then you also have an acute triangle, which means all three angles are acute less than 90. You have a right triangle, and there's only two different triangles that can be here, 45, 45, 90, and a 30, 60, 90. And then you have an obtuse, which means you have just one obtuse angle. Okay. All right, and so then the most important thing is if it's a right angle and you're missing a side, we can do Pythagorean theorem. And to do that, you have to know things about your right triangle. So straight across from your right angle is called your hypotenuse. So always look for your right angle. And then straight across from that is your hypotenuse. Okay, same thing here. Here's your right angle. There's your hypotenuse. And then the other two are legs.
Any more staples for the stapler tap?
So it's important to know where your hypotenuse is. So here's Pythagorean theorem. I'm sure some of you remember. It's c squared, which is your hypotenuse, is equal to your a squared plus your b squared. And you will use this to find a missing side of a right triangle. So if you're given a equals 3, b equals 4, find the hypotenuse. So if I draw my right triangle, and we're looking for the hypotenuse, such as your c. So that means c squared equals 3 squared plus 4 squared. 3 squared we know is 9. Remember, 3 squared means 3 times 3. Okay. 4 squared is 16. 9 plus 16 is 25. All right. Now, how do you get rid of something squared? Well, you have to take the square root of it. Whatever you do to one side, you must do to the other. So therefore, c is equal to 5. Okay, find an area of an isosceles triangle. So Okay, so I did some work on this already, but take a look at what we did here. So on this one, you cut this in half. So this would be your 3 inches. This becomes 1.5. And of course, here's your right angle. So you know 5 is your hypotenuse. And you plug it into your formula here. So 5 squared equals a squared plus 1.5 squared. So we know 5 squared is 25. And we know 1.5 squared is 2.25. We want to get your a squared by itself, so we subtract 2.25 from each side, and you end up with 22.75 equals your a squared. And then to get rid of your square, remember we take the square root, and you end up with 4.77. So this a is equal to 4.77. And then you have to find the area. Remember, area is equal to 1/2 base times height. So we plug this in, 1/2, 3 times 4.77, and you end up with 7.155, and this will be inches squared. Okay. All right, so here's a couple others. Just take a look at those real quick. Your base was 8. These are equilateral. And there is a formula in your book that you could use for this, but to me it's just as easy doing this. You break 8 up into 4 and 4. We know our hypotenuse is 8, so we plug it in. 8 squared equals a squared plus 4 squared. 8 squared is 64. 4 squared is 16. We subtract it. You end up with 48 equals a squared, and you do the square root, and you end up with 6.93. And then, of course, to find the area, we plug it into the area formula, 1/2 times your height, times your base, which is 8, times your height, which is 6.93, and you get 27.71 is the area. You do the same thing over here. Your 20 breaks up into 10 and 10. You know your hypotenuse is 20, so we fill it in. 20 squared equals a squared plus 10 squared. 20 squared is 400. 10 squared is 100. We move this over. You get 300, so 300 equals a squared. And then we do square root on both sides. And you end up with 17.32. We plug it back in the formula, and you end up with 173. Okay, and then here's a word problem. At a cost of $4.25 per square foot, what would it... Okay, just to finish this up, we were on this one. So again, if you're finding the cost of this triangular workspace is $4.25 per square foot, you have to do your area first. You get 64 feet, and then you multiply by the amount of money it costs per square footage, and you get $272. All right, a regular polygon is one in which all sides are the same length and all angles are the same. So if we're talking about finding the area of a hexagon, here's the formula: 3a squared, square root of 3, all divided by 2. A is your side length, which I have shown. All a's are the same. So in this problem, they want you to find the area of the hexagon given 4 inches is the side. Okay, so make sure when you plug this in the formula, you're very careful. So order of operations, you need to do exponents first. So 4 squared is 16. 16 times 3 is 48. Then you do 48 times square root of 3, and then divide it by 2. And you should get 41.569, and they want to round to 2 significant digits, so that would be about 42 inches squared. There are some other things you can find on a hexagon. You can find the distance across the corners, and you can also find the distance across the faces. The distance across the corners is represented by little d, and the distance across the faces is represented by little f. And these are the formulas. 2 times your side A is equal to your distance D. Or you could say half of the distance is equal to the side. And then the distance across the faces is 1.732 times your side length. Or you could say 0.577 times the faces. So here's a problem. If I give you a hexagon and the distance from its faces are 0.75, to find length A, we would first use this formula. A equals 0.577 times your faces. And then you do 0.577 times 0.75, because 3/4 is the same thing as 0.75, right? And you get 0.4325. So that's your length A. Part B wanted you to find the distance across the corners. So 2 times your A is equal to your distance, so you would do 2 times 0.43275, and that's going to give you 0.8655. And then part C, which is here, is you want to find the area. And we know A, which is right here, so we plug this in here. And so you end up with 0.49. Okay.